Good afternoon, all of you. In the previous lecture, I had discussed about the Favorski reaction by the use of different type of reagent. Okay, so today I am going to deliver lecture on Favorski reaction by the use of different type of living group. Okay, in the previous lecture, I had discussed by the use of different type of living group. Okay, now today I am going to explain different type of living group is used insist of halogen group. Okay, we know that the main substrate molecule of Favorski reaction is alpha haloketone. Okay, now look here, this is the structure of alpha haloketone. Okay, here Cl is a halogen group. Okay, and it present on the alpha position. Okay, so it is alpha haloketone. Okay, so today I am going to explain insist of halogen group at alpha position. We can also use a different type of leaving group. Like that, we can also use a N-bromopropyl as a leaving group in Favorski reaction. Insist of halogen group. We can also use a alkyl epoxide as a leaving group in Favorski reaction. Insist of halogen group. Okay. Here we can also use bromine ion. Okay, this is the halogen group is used in Favorski reaction as a leaving group. But instead of halogen group, we can also use a N-bromopropyl as a leaving group and also alkyl epoxide as a leaving group in Favorski reaction. We can also use a OTF is a leaving group in Favorski reaction. Insist of halogen group. Okay, so we can take 2 or 3 example by the use of different type of leaving group in Favorski reaction. We will see one by one. Okay, so Favorski reaction is nothing but the conversion of alpha haloketone into ester by the use of alkoxide. Okay, simply conversion of alpha haloketone into ester by the use of alkoxide. Okay, or we can use different type of reagent, so we will get a different type of product. When we use hydroxyl as a reagent, then we will get a acid as a product, and when we get a amide ion as a reagent, then we will get a amide as a product in Favorski reaction. Okay, so today I am going to explain the use of different type of leaving group in Favorski reaction. Now look here, I am writing the substrate molecule of Favorski reaction. Okay, this is the alpha haloketone. Okay, suppose here halogen group X is present. Okay, so insist of this halogen group, here I am taken N propyl brom, N bromopropyl as a leaving group. Okay, insist of halogen group. Okay, so what will happen when we use this type of leaving group in Favorski reaction? Now look here, the mechanism of reaction is same. Okay, in the first step, the reagent alkoxide is act as a base. Okay, and it extracts the acidic proton on the left side of the substrate molecule. Here 2 acidic proton will be present. Okay, so firstly this OR negative reagent is extract this acidic proton. Due to which this negative bond shifted toward this carbon atom, and this carbon bear a negative charge, and we will get this type of intermediate product. Okay, here deprotonation takes place by the use of reagent alkoxide. Okay. After the formation of this type of intermediate product, we want to generate a cyclopropanol intermediate. Okay, so it will be generated by the breaking of this bond. Okay, when we break this bond, bromine have a more electronegativity, so it generate a negative charge and this carbon generate a positive charge. Okay, so here bromine will be removed. Okay, after that this bond will be break. Okay, so this carbon bear a negative charge and this carbon bear a positive charge. Okay, so this negative charge of carbon is attacked on this positive charge carbon like SN2 type. Okay, so due to which here in between bond will be generated and we will get a cyclopropanol intermediate. Simultaneously, this positive charge carbon and this negative charge carbon bond a pi bond, form a pi bond. Okay, so here bromine will be removed and we will get another intermediate product like that. Okay, here bromine will be removed. So we will get this type of cyclopropanol intermediate product. Okay, after the formation of this intermediate product, the remaining alcohol oxide group. Okay, we know that in Favorski reaction the base is used in excess quantity. So firstly this base act as a base and the remaining base is the remaining reagent it act as a nucleophile. Okay, so this alcohol oxide nucleophile attack on this electrophilic carbon atom of carbonyl compound. So what will happen by the attack of nucleophile OR negative? This pi bond shifted toward the oxygen. Okay, and oxygen contain negative charge, and we will get these type of intermediate product. Here oxygen contain negative charge and this carbon bonded with this alcohol oxide group. Okay, so we will get this type of oxonium and cyclopropanol. Sorry, we will get this type of intermediate product. Okay, so we want to neutralize this negative charge of oxygen. We know that we neutralize this negative charge of oxygen by the two ways. The first way to breaking of this bond and the second way to breaking of this bond. So firstly we will break this bond. So when we break this bond, this carbon bear negative charge and this carbon bear positive charge. Okay, so this negative charge carbon, positive charge carbon and negative charge oxygen form a pi bond, and we will get this type of another intermediate product. Okay, here ring contraction will be take place. This is the 6 member ring. Okay, after the breaking of this bond, this ring is converted into 5 member. Okay, so this carbon bear negative charge, this carbon have oxygen double bond and one alcohol oxide group. Okay, so we will get this type of intermediate product after the breaking of one bond for the neutralization of negative charge of oxygen. Okay, so after this formation, this intermediate extract proton from the first step removing proton. Okay, in the first step this acidic proton will be removed, so this negative charge carbon extract this proton and neutralize this negative charge, and we will get our final product called as ester. Okay, so when we use alcohol oxide as a reagent, then we will get ester product. When we use hydroxyl functional group as a reagent, so we will get acid product. And when we use amide ion as a reagent, then we will get amide product. So in this reaction we will use alcohol oxide, so we will get ester product. Okay, the main point is in this reaction, here we can use N-bromopropyl as a leading group insists of halogen group Cl, Br or ion. Okay, we can use this type of leading group. Okay. So these are the simple example of Favorski reaction by the use of different type of leading group. Okay, at the place of N-bromopropyl we can also use an alkyl oxide epoxide as a leading group. Now look here, I am erase all of this. Okay, and at the place of N-propyl bromide we can use alkyl epoxide. Okay, as a leading group instead of halogen group. Okay, so what will happen in this reaction? The reaction mechanism is same. Here we can use oxide as a reagent. Okay, so we will generate a acid product. Okay, so in the first step this hydroxyl ion extract this acidic proton to form this type of intermediate product. Okay, here negative charge develop on this carbon atom because of their deprotonation take place in the presence of base hydroxyl ion. Okay, after the formation of this intermediate we want to generate cyclopropanol intermediate. Okay, so cyclopropanol intermediate is generated by the breaking of this bond and this bond. Okay, so firstly we will break this bond. Okay, after the breaking of this bond oxygen bear negative charge because of oxygen have a low more electronegativity than the carbon, and this carbon bear a positive charge. Okay, after that break this bond. Okay, after the breaking of this bond this carbon bear negative charge and this carbon bear positive charge. Okay, so this negative charge carbon is attacked on this carbon atom like SN2 type. So here bond will be generated and we will get a cyclopropanol as an intermediate product. Okay, also this pi bond, here pi bond will be generated in between negative and positive charge, so we will get this type of intermediate like that. Okay, here one bond will be generated and also here one pi bond will be generated. Okay, so we will get this type of intermediate product. Okay, after the formation of this type of intermediate product the remaining the remaining reagent is attacked as a nucleophile on this electrophilic carbon atom of the carbonyl compound. So by the attacking of this nucleophile OH we will get this type of product, intermediate product here. Okay, so this type of intermediate product is generated by the attacking of nucleophile OH on the electrophilic carbon atom of the carbonyl compound. Okay, so after the formation of this product we want to neutralize this negative charge of oxygen. We know that this charge is neutralized by the two way, by the breaking of this bond and by the breaking of this bond. So we will break this bond. Okay, after the breaking of this bond this carbon generate negative charge, this carbon generate positive charge. Here the positive charge carbon and negative charge oxygen generated a pi bond and we will get this type of 5-member intermediate product. Here this carbon generates negative charge, this carbon is bonded with this bond carbon, here carbon generated double bond O and here one hydroxyl group is present. Okay, and this carbon contains this chain. Okay. So after the formation of this type of intermediate product, here simple protonation takes place. Okay. So after the protonation, here we can generate a final product like that. Okay. This negative charge of carbon is stabilized by the abstraction of proton, and this negative charge of oxygen is also neutralized by the abstraction of proton. Okay. So here we can take excess quantity of H proton. So we will get this type of final product acid. Okay. So in this reaction we can use a reagent as a hydroxyl group, so we will get acid product. The main point is in this reaction we can use alkyl epoxide as a leaving group instead of halogen group. Okay. The mechanism and the reaction is same as like we can see in the first lecture and second lecture. Okay. So this is all about the Favorski reaction. Okay. I hope you will be understand better. If you have any problem regarding to this topic, you can ask me personally. Okay. Firstly, we will see the Favorski reaction. Simple. In the second lecture, we can use a different type of reagent, and in the third lecture, we can use a different type of leaving group used in the Favorski reaction. Okay.